Hi guys, welcome back to QBT. We're continuing our forces series in this video with this lovely equation over here. This equation helps us to understand the acceleration, that's what the A is, that something is experiencing. Okay, so if I take Steve, this is Steve, he's a plant dino plant. I'm not sure what he is, but I like him. If he is stationary and he zooms along, right, looking for his food, he's accelerating and he's traveling his distance in a particular time, right? And all of these variables are here in this equation. So let's walk through it in detail, and then I'm going to talk to you about how we can actually apply our knowledge in a guided explanation. So A is our acceleration, right? And acceleration simply refers to the rate of change of velocity over the time that happens in. Okay, so V refers to an object's final velocity, right? So if a car is traveling and it's accelerating and then it reaches 70 miles an hour or 30 something meters per second, then that means that its V is about 70 miles an hour. U, just here, U I've put initial, right? Because this is the object's starting velocity before the acceleration occurs, right? So in the case of Steve, he was stationary, so his initial velocity is 0. But if he's traveling at, say, 2 meters per second before he starts to accelerate, and he reaches 10 meters per second, then his initial velocity would be 2. Okay? So V is your final velocity, U is your initial velocity. And then T is just time. And that's in seconds. So what we're doing is, we're calculating the change in the velocity, the final velocity minus the initial velocity, and we're dividing it by the time that it takes for that to occur. And this is what gives us our acceleration. Why don't you take a look at this explanation, and maybe it will help you understand it a bit more.
Alright, so let's use our knowledge of our new equation, A equals V minus U over T, to solve this question. Let's have a look. So, a car is parked before it accelerates to a velocity of 5.6 meters per second. It takes 2 minutes to do so. Find how quickly it accelerated. Okay, so every time we have a question like this, the first thing that we do is write down the information that we have. Okay, well, what information do we have? We know that the final velocity is 5.6 meters per second. So V is equal to 5.6 meters per second. And we know the time is equal to 2 minutes. But we need to convert that to seconds, right? And we know that because there's 60 seconds in 1 minute, we can multiply this by 60. And that converts it to 120 seconds. Remember, we're always doing things in standardized units. Okay, so we've got our velocity and we've got our time. What about our initial velocity? Well, we know that the car is parked. And we know that when something is stationary, it doesn't have a velocity because it's not moving. So U is 0 meters per second. Okay, so now we have all of our information. We need to just plug in the numbers. So A would equal V, which is 5.6, minus 0, which is U, divided by 120. Okay, and if you put that into your calculator, then you should get a value of 0.046 recurring. The 6's go on for quite a while, right? And we can round this to 0.05 meters per second squared. And that is our answer. Okay, so when you have questions like this, guys, just remember to write down the information that you know, and then what you're looking for, rearrange for what you're looking for, make that the subject, and then plug in your numbers. Okay, do it slowly, take your time, and you'll get the right answer.
Alright, so I hope that guided walkthrough helped you understand the equation a little bit more and how you might use it in an exam question. But that's it for today. We're done with acceleration. But I hope you learned something, I hope that you found it valuable, and we'll see you next time. And remember to stay quantum. Bye guys.